We are discussing on the quality control and quality assurance for the bituminous material. Previously we have seen one of the tests which has to be performed on the bituminous material, and that was the penetration test. Next, the important test which named as a viscosity test, which gives the property of bitumen to flow. So let's discuss about viscosity. What is viscosity? Well, a term viscosity is for consistency, and it gives a measure of resistance to flow. In a general way, viscosity is defined as the inverse of fluidity. Fluidity, that means a material which can flow easily and smoothly with a proper speed, wherein viscosity is kind of fluid with the high density. The viscosity thus defines the fluid property of bituminous material. Many researchers believe that the grading of bitumen should be by absolute viscosity units instead of the conventional penetration unit. The degree of fluidity of the binder at the application temperature greatly influence the strength characteristics of resulting paving mixes. High or low viscosity during the mixing or the compaction has been observed to result in lower stability values. There is an optimum value of viscosity for each aggregate gradation of the mix and the bitumen grade. If we talk about low viscosity, so at the low viscosity, the bituminous binder simply lubricates the aggregate particles instead of providing a uniform film for binding action. Similar way, for the high viscosity, it also resists the compactive effort, and the resulting mix is heterogeneously in character, exhibiting the low stability values. The viscosity of tar is determined as the time taken in seconds for 50 ml of the sample at flow through 10 mm orifice of the standard tar viscometer at few specified temperature, that is 35 degree, 40 degree, 45 degree and 55 degree. As you can see in this figure that there is a flask, we have a bitumen sample. At the initial stage, we have poured the sample in this bucket. Then after we have increased the temperature, we are giving heat to this bituminous sample. This bucket have a orifice at the bottom surface. Now once you have poured the bitumen, then after you are giving heat to this particular specimen, at few temperature it starting melting. Okay, so at a temperature this bitumen gets melt and it get fall into the flask at the different temperature. So as this bituminous material get melt and get fall down into this flask, the time required for 50 ml of material to be fall down is to be measured, and from that we will consider the viscosity or the viscous property of that bitumen. So as per this particular test, higher the time taken by the bitumen to get to fall down into the flask will be considered as a higher viscosity of that particular bitumen material. And the viscosity of a cut-pack bitumen is determined as the time taken in seconds for again 50 ml of the sample to flow through either 4 orifice at 25 degrees Celsius or at 10 orifice for 25 to 40 degrees Celsius temperature. Thus, the orifice viscometer is suitable to taste tars and cutbacks. If we talk about cutbacks, then here we can see that we have two different values. That if you are using 4 mm of orifice, the viscosity of cutback bitumen is determined as the time taken in seconds for 50 ml of the sample to flow through either 4 mm orifice at 25 degree temperature and 10 mm orifice at 25 or 40 degree temperature, and thus the orifice viscometer is the suitable to taste tar and cutbacks both. So this is what about the taste of viscosity. Next we will see the softening point. Now the softening point taste. The softening point is the temperature at which the substance attains a particular degree of softening under specified condition of taste. If we talk about the bitumen, the softening point of bitumen is usually determined by ring and ball taste. This figure shows the arrangement of the ring and ball taste, wherein here you can see a ring and above that a bituminous ball is placed. Generally, the higher softening point indicates lower temperature, susceptibility and preferred in warm climates. If a bitumen have higher softening point, that means this kind of bitumen is preferred to use in the warm climate. So this indicates that if the softening point the temperature is high, that means if a bitumen gets softened at the 50 degree temperature, that means that kind of bitumen you can use in the warm atmosphere, in the warm climates. So let's talk about this taste. Here a brass ring containing a taste sample of a bitumen is suspended in a liquid like a water or a glycerin at a given temperature. Here you can see these rings. Yes, so this ring is to be suspended in water or else a glycerin at given temperature. That would be there would be a specified temperature, initial temperature, and at that temperature we starting the taste on the bitumen. Well, a steel ball is placed upon the bitumen sample and the liquid medium is then heated at a rate of 5 degree per minute. This can be asked in MCQ, that at what rate the bitumen sample and the liquid medium is get heated for the softening point taste. So the answer would be at a rate of 5 degrees Celsius per minute. The temperature at which the softened bitumen touches the metal placed at a specified distance below the ring is recorded as the softening point of a bitumen. As it is shown in this figure, that at the initial stage the bitumen and this ball, bitumen is inside this ring, and this is a ball, a steel ball. So when you increase the temperature, the bitumen get melt because of the warm atmosphere of water, as well as with that bitumen also get heated. So at the moment this steel ball touches the below plate, that temperature is to be measured, and that would be the softening point of the bitumen. So that was, this line says that the temperature at which the softened bitumen, this is a softened bitumen, touches the metal placed at specified distance. This is a metal which is placed at some specified distance below the ring, is this temperature is to be recorded as the softening point of a bitumen. A hard grade bitumen possesses higher softening point than the soft grade bitumen. The softening point of the various bitumen grades used in paving job or used in the pavement varies between 35 degree Celsius to the 70 degree Celsius. So this is what actually about the softening point of a bitumen. Next is the float test. Float test. There is a range consistency of the bituminous material for which neither an orifice viscometer test nor a penetration test could be used to define the consistency of the material. So basically we can say, to measure the consistency of the bituminous material, the float test has to be performed. The consistency of materials of this group is measured by this float test. The apparatus consists of a float made of aluminum and a brass collar. This collar is also called as a mold. So a brass mold filled with the specimen material to be tested, which is screwed in the float as shown here in the figure. This is a mold, or we can say collar, and this is a float of weight 3.8 kg. The test specimen is filled in mold, cooled to a temperature of 5 degree and screwed into the float. So at the initial stage, what you need to do, that you have a bituminous material. First of all, you have to keep that material, or you have to make it cooled at a temperature of 5 degree Celsius. After that, that bitumen will get kind of at its dense format, okay, and after that, that bitumen has to be screwed into the mold or into the float. Now next step is that float assembly. The float with that mold is kind of float assembly. So that float assembly is now floated in a water bath at the degree of 50 degrees Celsius, at the temperature of 50 degrees Celsius, and the time required in a second for water to force its way through the bitumen plug is noted as the float test value. Here we have bitumen in a mold. This is a float. We have kept this float assembly at 50 degree temperature water. So now after some time, this bitumen get melt and get come over on the float, and after that this water will comes out this water will find its way through that bitumen, and that time has to be noted, and that is known as, or that will give you the value of stiffness, the value of the consistency of the material. So basically, the higher the float test value, the stiffer is the material. This is what this test gives at the end, at the conclusion. So in this lecture, we have learned about the first one, that is viscosity test. After viscosity test, we have learned about softening point of the bitumen, and then after the at the last we have gone through the float test. This test gives the different characteristics of the bitumen. So we will continue the discussion on the bituminous test